the two functions. So graphing sine and cosine. So how can you graph those? First of all, the sine function is on the left. And if you notice the sine function, a regular sine graph goes through the point 0, 0. So you do need to kind of know that. If you look at a cosine graph, it does not. It starts up here. Okay, so that's one major difference like between the sine and cosine graph. So if I go to Desmos right away and I put in y equals the sine of x, you'll see that graph. You see it goes through the point 0, 0. But if I go and type in y equals cosine of x, you see they're very similar in the pattern, but you see the cosine graph actually starts at 0, 1, so it doesn't cross the origin. Now, I can move it and make it cross the origin and things like that. But their patterns are very similar. Okay, it looks like waves, mountains, whatever you want to call it. But those are both the graphs. So sine and cosine is an easy one to see how it's used in real life. So a sine graph is one that if we change it around to make it, something like this, then you can kind of easily see what that is. That would be like your heart rate, right? So if you ever been hooked up to monitor or had somebody, there's your heart rate right there, and then you want it to be that and not this, right? Okay, so there would be your sine graph. So they use a sine graph to tell if you have any irregularities there in your heart rate, and they should be symmetric. They're not. Everybody's is not exactly symmetric, but it is pretty close when they go through that. So there is your real world application for it pretty quickly on that. Now, as we go back to sine and cosine, there's three important things on vocabulary. The first is the amplitude. Amplitude is half the difference between the maximum and the minimum. Another way of saying that is how far up and how far down does it go. Okay, so on Desmos, if you look at the regular sine graph, the highest it goes to is positive 1, and the lowest it goes to is negative 1. That's a distance of 2, and half of that is 1. But another way of saying the amplitude is how far does it go up and how far does it go down. It goes up and down 1 in each direction. So the amplitude is how high and how low does the graph go from the middle. Okay, so that's your amplitude. You have a cycle. A cycle is one complete pattern in a graph. And there's a formula for these two, so that's where you have to be careful. It's 2 pi over the period. Now, if you kind of rearrange this formula by multiplying by the period and then dividing by b, you can see that a period is 2 pi over b. So how long it takes to complete a cycle before the pattern repeats itself. A lot of times they ask for the period because it's basically when does the pattern begin to repeat itself. So in general, like let's say the pattern is right here at the top. It goes through the whole, all the way down, all the way back up, and then it would begin to repeat itself, okay? That is from pi over 2 until 5 pi over 2. That would be a distance of 4 pi over 2, which is 2 pi. So typically in the regular function, 2 pi, which was the same thing as the unit circle, right? When you make a circle, is your period. Now, it's going to change based on what you plug into the numbers. You can make the period smaller, which means it happens more rapidly, or you can make it longer, which means it takes a longer period of time for it to happen. So you can go through and see the difference there, but it's easy to find the period by looking and clicking on the buttons for when it repeats itself. Okay, but there's also a formula in the equation as well. So there's two parts to that. Sorry, there's my calculator. All right, so If we go back, we have amplitude, cycle, and period, and we'll talk about the formulas in a second. So example 1 says, sketch one cycle of the equation y equals 3 sine of 2 pi, and then it says theta. That's just like x, right? Sine of 2 pi x. So if we go to our calculator and you go to Desmos, you can graph this. So the typical equation, notice, for sine is y equals a sine b and then theta, the angle. So a in example number 1 is what? 3. So a is 3. B is what's in front of theta, which is 2 pi. All right. And then the period. Now, for you look at the period is 2 pi over b. So in this case, it's 2 pi over 2 pi. So the period would be 1 for this one, because it's 2 pi over b, but we just said b was 2 pi. So the period is 1. So we can go and look at the graph. So 3 sine of 2 pi theta. Let's see. Y equals 3 sine of 2 pi. Okay. And that's it right there. Notice where it starts over. Does everybody see how that's 1? How the period is 1? It starts over at 0.25, 1.25, 2.25, 3.25, 4.25, 5.25. Now, how can I graph this? Well, it depends. It depends how you're looking at your lines going up and down. The highest this one goes to is 3, and the lowest it goes to is -3. That tells you that's your amplitude. Your amplitude is always a positive number. It's saying how far does it go in each direction, up and down. So your amplitude's 3. You see where that comes from? That comes from the number right here. Your period is 1. That's how far before it restarts. Your period comes from 2 pi divided by this number. And those are the two very important things to get here. So again, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9. You could go up 3 and down 3. And you see that at each one, this is where it's going to hit. So it's going to hit all the way here, and then it's just going to restart. You're just going down, back up, down, back up, down, back up, down, back up. Yes. What is B? So if A is -1 in example 2, because of that negative, if B is pi over 2, your period is 2 pi over 2. So 2 pi divided by pi over 2, which would be the same thing as, so you got 2 pi divided by pi over 2, which is the same thing as saying 2 pi times 2 over pi, which means your pi's would cancel out. So it would be 4 would be your period. Okay, so your period is 2 pi divided by b. Well, b was pi over 2. So 2 pi divided by pi over 2 is the same thing as 2 pi times 2 over pi, because we flipped the second fraction. The pi's cancel out, and so you get 4 as your period. Now let's see what it looks like. Negative cosine of pi over 2. Again, theta can be x. So negative cosine of pi over 2x. And my x in the wrong place. Now, the normal cosine graph crosses at 1, like above. If you look at the the very beginning example, But this one crosses that negative one. The reason why is because of that negative in front. Okay, it caused the graph to flip, basically, from the normal cosine graph. The normal cosine graph would look like this, cosine of x. Notice, looks like that, but this one has flipped. That's why it goes down to negative 1. That negative 1 also tells us our amplitude is 1, so the highest it goes to. That means right here from 0 it goes up 1 and down 1. Notice I talked about our period is 4. The period is 4, so if you look at this right here, if we take this point right here, it goes down and back up. It took it from 2 to 6 to do that. That was 4. If it goes down and back up, that would be at negative 2. That's 4. So the distance is 4. So the period is a very important part of the sine and cosine graphs because it tells you how long it's taking before it restarts again, basically, before it goes through again. The amplitude is very important because it's telling you how far up and down it's going to go. Notice if I change the amplitude to something like 3, see, now it goes up to 3 and down to negative 3. If I change it to 5, it's even higher, 6, right? But if I keep it at 1, you see it's just going up and down 1. So you can change things in the graph that will, again, change the amplitude, and the period will change the way the graph looks. Example numbers 3 and 4, you can try these. So you want to say, what is A in the problem? What is B? Find the period. Remember, the period is 2 pi divided by B. If B is a fraction, like it is in these two problems, you're just going to flip the fraction and multiply to find the period. And then it wants you to sketch that, okay, to sketch the equation of the graph. And I already tell you it may go off the paper. If it does, that's fine, because you see the amplitude there would be 4, and in the other one the amplitude's 5. So if it goes off your graph by a little bit, that's okay. So try to sketch these two using Desmos, but find A, find B, and find the period. X, remember theta is just x, so negative 4 sine of 1/2 x is going to be our first one to look at. And go type that in. Y equals negative 4 sine parentheses 1/2 x, and then close the parentheses. So that one crosses at 0, 0. You see it's going down 4 and up 4. That's the amplitude is 4. It's negative because it starts by going down. So that helps you see why it's negative. And then you can see the period takes you all the way from negative pi. And when I click on the other one, that's 3 pi. So what was the period there?
4 pi.
Yeah, it's 4 pi because it goes from negative 1 pi all the way to 3 pi. So notice the next time it would get there would be 7 pi, right? So you can see the period is 4 pi. That's how long it's taken it. Because 2 pi divided by 1/2 is the same thing as 2 pi times 2 over 1, which is 4 pi. So that was that one. The one on the right, 5 cosine of pi over 4x. So 5 is going to be our amplitude. Cosine of pi over 4x. And so you can see here, cosine, does it cross at 0, 0? It's actually going to cross at 5 on this one because of that amplitude of 5. The pi over 4, so if we click here and we click here, pi over 4, 2 pi divided by pi over 4 would be 2 pi times 4 over pi. So the pi's would cancel out, and 2 times 4 is 8. So you see our period would be 8. It would take 8 until it repeats. So you see for every 8, you see a repetition there. The amplitude is how high and how low it goes, so that's 5. And then the period there was pi over 4. So actually, if you think the B, is pi over 4, the period is 8. So if you think about it, the smaller the B is, that actually means the greater, what happens is you get a larger period there. And because you're changing that, because you're dividing by a much smaller number. The bigger your B, or the number in front of X, then the smaller the period would be. So that's how the graphs of sine and cosine work. And that's all you need to know basically for today. So the second page of that, I'm not even going to mess with because we just have to take things. We're taking things one at a time. So we're going to work on, this is what you need to know in the Math 3 right now for today is how to graph a sine and cosine function using the calculator, how to know what's A, what's B, and what is the period if that was a question. Tomorrow's says translating a sine and cosine function. That would mean moving it left, right, up, down. Okay. Right now, we're just seeing bigger, smaller, wider, narrower. Tomorrow, we want to talk about, well, look what happens if you do plus 2 here. Okay. Now it goes from -3 to 7. Right? What if I do -2? Now it only goes from 3 to -7. So we're going to see like how it changes when you change things on the outside. It changes things. What if I -2 on the inside? Right? What's going to happen when I subtract 2 in here? It's going to move it over, right? Whereas it would be right there. What happens if I add 2 on the inside? It's going to move it different direction. So we're going to talk about translating the graphs left, right, up, and down after we learn how to graph a sine and cosine function. And then that will wrap up the unit on trigonometry. Okay? So for today,